In this video, let us look at the derivative of sine function from first principle. We know from the definition of the derivative of a function, ddx of any function is given by the limit as h tends to 0 of f of x plus h minus f of x upon h. So now if we have f of x as sine x, this implies that f of x plus h will be equal to sine x plus h. So now let us put in this formula that the derivative of sine x with respect to x will be given by the limit as h tends to 0. So let us substitute here. We shall get sine of x plus h minus sine x upon h. We are going to recall that from trigonometry, sine of an angle minus sine of another angle has got an identity. Let us say if you have sine A minus sine B, this is same as 2 sine A plus B over 2. I beg your pardon, it is cos A plus B over 2. This is A plus B over 2 sine A minus B over 2. So we are going to apply this identity here, where we have sine x plus h minus sine x. So this part here will act as our A, the x plus h, and the B, x will act as our b. So let us apply the identity here. So we shall have our derivative as the limit as h tends to 0. So we shall get 2 cos. Now I want you to observe here that if we were to take a plus b, like in the identity here, we shall be taking x plus h plus x divided by 2. So x plus x, that is 2 x, then plus h divided by 2, you get x plus h divided by 2. And sine A minus B, that means we are going to take x plus h minus x. So we remain with h. So it will be h over 2 upon h. Alright, now I'm going to split this expression here. This is the same as the limit as h tends to 0. I'm going to first extract this cos here alone, then it will be cos x plus h over 2. Again, I take 2 sine h over 2, which will be times 2 sine h over 2 So this is the same thing. Now I'm going to rewrite the same expression. So I'll get limit as h tends to 0 of cos x plus h over 2 times, now this one can as well be written as sine h over 2 over h over 2. Now from the theorem of limits, you must know that the limit, let's say x tends to 0 for sine x over x is equal to 1. So this is a useful theorem in limits. So you can see that it is appearing here. We have sine h over 2, then all upon h over 2. So as h tends to 0, this one will give us a 1. But this one here is going to give us 0 plus x, so remain with cos x. Therefore, we get, if we apply the limit of h as x tends to 0, this one becomes cos x times, now this one will give us 1, that is times 1. Therefore, the derivative of sine is given by cos, gives us a cos. So that is how we get the derivative of sine from first principle.